All right, so this is my Unit 2 lab activity review presentation that I have done. As you can see on here, I did my work with density, and I am Martha McKay. So my first slide, the virtual lab, that was the mode for the lab activity that I did. I did not do anything hands-on. I got it from online chem labs, and I actually performed the density one, as my students quite frequently do density labs in all of my classes. So the basic setup of the lab was very simple in that I can easily change it if mistakes are made. I can go back and complete the entire lab and then clear out all my answers and start over again. I can enter them in multiple times to keep trying it over and over and over again. But I also have to write down some of the measurements that I took or that I got so that I could use them later. And that type of stuff can be adjusted all the time. So it frequently would tell me answered, but then changes allowed. So I could go back and change it or recalculate my volume if I needed to, or if I figured out that I had done it incorrectly. And at the top of the screen, there were buttons to allow me, just arrow buttons to allow me to go forward and back, which made it really nice and user-friendly. It did ask me at the very end when I was done, I wanted to clear everything out so that I could potentially start over again. And it gave me, a button that I could hit clear all answers. But then it brought up this prompt to make sure that I wanted to clear everything out. So, which was kind of cool and I thought was nice that instead of just clearing it all out, it gave me some sort of a prompt. The time spent. Now, I do realize that as a teacher, I know how to calculate density. I don't have to be taught how to calculate density. I know how to take the mass of things. I know how to calculate volume. So for me, it only took me about 10 minutes, maybe even a little bit less, to go through the entire lab because honestly, I did not have to read every single thing that was on there. I intuitively knew that I could click on one of the objects and move it to get the mass, and I already know how to calculate volume, so I didn't have to go through the tutorial part on how to learn how to calculate volume or go back and hunt for that information, as I recognized that information already. So because I understood the basic procedure for it, for me, it didn't take very long. But for a kid, I was thinking about like a freshman in high school who really is not that familiar with density. It would probably take 30 to 45 minutes if you did that lab correctly. There's only 10 real slides to go through. But if you do all the calculations like it says to, and you do all the manipulations and you practice, it's probably going to take 30 to 45 minutes to complete that lab. So this is kind of what it looks like, the basic format of it. And like I said right here, it has previous and next buttons, so you can go back and forth between the 10 different slides. It starts with an introduction. It gives you the 3 materials you're going to work with, a scale, and then the next couple of slides give you instructions on how this scale works, and it tells you how to move the different objects around. So the slides would have, or this introduction and the reading portion would be green and sometimes pink, like it would turn pink when I got something done. So if you intuitively knew how to do this already, you would be fine. But if you were a person who had never done anything like this before, it's going to take you a little bit longer to figure out how to do it. So the virtual lab versus the on-campus lab, I have to say for density, an on-campus lab is probably still better, or a kitchen chemistry lab, or a hands-on, because density is such an abstract concept. And this, you can pick something up and feel how heavy it is. When you're doing a lab like the virtual lab, you don't get that concrete analysis portion of it. You just get the abstractly, well, okay, that has a higher mass and a lower volume, so that one's more dense. But the measurements are very basic. It's easy to use. The scale does all the work for you. You're not moving a triple beam balance or even having to really press the tare button and putting something on a scale like you would to actually perform the traditional lab. The calculations for volume, though, they just give you one of the dimensions of the cube, and you have to know that volume is length times width times height. And if you have a cube, all of the sides are going to be the same. So it doesn't quite take you through how to figure the volume as well. Like you would have to if you were doing a traditional lab. You would have to take a ruler and you would measure the length, the width, and the height. So again, you're missing that hands-on concrete. You're just getting this abstract analysis. So this is what the scale looks like. It does have a tear button and a record button, and you can have it record to different units. So you would move the object onto it and hit record. And then this is like what it told me for the volume. It just said, enter this value in your notebook. The plastic cube has an edge length of 2.2 or 3.23 centimeters on each side. So I would record this in my notebook, and I knew already that I would need this information to calculate volume by doing length times width times height, and it's a cube, so they're all going to be the same. A student might not know that. So the way to calculate volume was not clear. So more stuff on virtual lab versus the on-campus lab. The instructions are easy to follow, as parts do change color or they say completed when you're done. In the traditional lab setting, though, you don't have that. You just have to keep going through and filling in. You might have blanks to fill in, but if you skip a step, nothing is there to prompt you to go back to fill something in. You might never realize that you skipped a step. The measurements are, again, very basic and simple, and almost too simple. You're only working with 3 materials, and those 3 materials, again, are really abstract. You might not even know what they are. Whereas in a traditional lab setting, you might work with a whole bunch of different things: irregular shaped objects, regular shaped objects. Whereas in this virtual lab, you did not work with any irregular shaped objects at all. You were able to calculate the volume by the dimensions that they gave you, or they just flat out told you what the volume was. So again, you miss out on that concrete examples. It's still just very abstract. So here it said completed when I finished that stuff, but these answers could be wrong. So it did not say correct, it just said completed. And then the last slide, slide number 10, had me go through and calculate, using the volume, using the significant figures. It had me go through and divide to figure the density. But this was really all it did. And then it just had me identify what object it was. It didn't have me, rationalize that for, is that really heavy or is that light? Is that going to sink in water? Is that going to float in water? There wasn't much analysis part to it. Some technical issues. I ran into a lot of technical issues. I ended up having to use a student's MacBook that I had to borrow because I was at a loss for how I was going to get this to run. And I had tried it on 4 different computers with 4 different systems running on them. And I finally got it to run on the student's MacBook, who let me borrow it so I could complete the lab and take some screenshots while I was doing the lab. It requires Internet Explorer, not Edge, and I could never really override Edge to allow Internet Explorer to run, and all of our students have Chromebooks, so it definitely wasn't going to work on that. And my teacher computer, I downloaded it, and it still said that it wasn't installed. So I tried to run it as administrator, and that didn't work. It was many days of wasted time to try to get it to work and to run, but once I did, it was really easy. So I had major technical issues. If I was a student, I probably would have had to have dropped the class because there's going to be due dates. And if I can't fulfill the labs by those due dates, I'm going to be in trouble. So from a student standpoint, you just can't go and try 5 different computers. You might only have access to 2 in a public computer lab or a computer lab at a library. You just might not have access to different computers to try that, or even the availability of a computer for you to download stuff onto. So fortunately, they are going to be addressing the Starlight issues and allowing these labs to run without Starlight or anything like that. But for right now, that didn't help me right now. It still wouldn't work. So for the assessments, I would use the assessment tool from the virtual lab for a grade. I would have the kids, export or upload that to me. I would have them turn it into me because it does keep track of all their stuff. I would also have them take pictures of the work that they did because there are things you have to write down on paper and it prompts you to. So as instructed in the lab. So I would have them take a picture and send that to me. So the full lab report can be exported plus those pictures. I would also assign the students some extra density problems that might have them actually calculate volume of an object, or I could have them do some sort of a kitchen chemistry thing where I have them find 3 objects and calculate the density of that and report what those objects are. So it could be, a very real world, or it could be, just more density problems just to give them some extra examples. So here's the lab report that would get turned in, and you can see it's going to keep track of all of the different things that I took measurements on, and then I can have them turn that in. By clicking the refresh button, it does fill in all of my data as I take it, and I can clear all the answers. I can clear the experimental answers. So there are opportunities to go back to do this lab over again. So, and more with the assessment, I would probably set up some sort of a discussion forum, or I would have the kids answer some analysis questions rather than just what is the density. I'd have them do some analysis, like how would you find the density of an irregularly shaped object, which it really didn't have them do. Which object would feel the heaviest and why? I would have them try to explain what density really is. I would have them take some examples where I might give them some materials and give them their densities and say, now put these in order. How would they settle out of solution if they were all in water? Which one would sink? Which one would float, and why? I would also have them try to come up with some real world application for density. A lot of times my students, when I have them do this, will come up with, well, why does a boat float? And then we start talking about buoyancy. That's a very real world application for density. Or why does a person that is much more muscular sink in water and have a hard time floating than a person who has more fat? So those would be some applications that I would hopefully lead them in some discussions that I could get them to have with each other, or I could prompt them to have to see why density is important. So a little bit of reflection. I thought the lab was really easy. It's pretty easy to understand. The calculations are not difficult. There's prompts for everything. If a person, like I said earlier, if a person has no experience with anything like this, it might take them a little while to learn how to do it, but the instructions are there, so they're just going to have to be more careful when they read the directions, but they're all there. So it's just going to take them a little bit longer. I really liked that there was a progress bar. So as I clicked next, like this next button, it would tell me where I was at in terms of the lab. So I could click back and forth between things as needed, but I would always have an idea of where I was at in terms of the overall lab. And since this does apply for me, this lab would be very applicable for me for my physical science and chemistry courses. It might be slightly too easy for my chemistry students, but it would work for my physical science freshmen. I can do this lab with my chemistry students as a quick review of density, or if I had somebody that was struggling with density, I could have them start here. If kids were absent from the hands-on density lab, I could have them do something like this for a traditional lab. So I could see myself using this lab either as review or as an alternative to a hands-on lab. But I think my freshmen really do need the hands-on. Let's actually touch this and feel this so they can understand concretely what they're doing. And this is the standard that it goes with, the next generation science standards, the matter and its interactions. Construct and revise an explanation for the outcome of a simple chemical reaction based on the outermost electron states of atoms, trends in the periodic table, and knowledge of the patterns of chemical properties. This is very much background knowledge for the kids to understand just trends in the periodic table, as well as some of the properties or patterns we see with chemical properties, like the patterns in metals as you go across. What is the trend for density as you go across? And why would something that's more dense react versus something that's less dense, and vice versa. So it's just later on when we actually start talking about chemical reactions and how things settle out of solution, when we talk about, precipitate settling to the bottom, or this layer settling to the, coming out on the top, and we separate this layer out, all of that stuff is related to density. So even though density is not specifically mentioned here, it is one of the chemical properties or one of the physical properties of matter. So that's the end of my presentation. I really enjoyed doing this lab, and I would have my kids do it again.